Hi all, welcome to Mental Minds. Today we are going to do problems related to the chapter Mirrors and Lenses. So let's get into the video. Our first question is, a ray makes an angle of 35 degrees with the mirror surface. Find the angle of reflection. So to do this problem, we have to draw this mirror. This is the plane mirror, and this one is the normal, and this is the incident ray, and this is the reflected ray. Okay, so this is the angle of incidence and this is the angle of reflection. In the question it is given, a ray makes 35 degree, that is 35 degree with the mirror surface. So here the mirror surface is this one. This ray, incident ray, makes an angle of 35 degree with the mirror surface, means the angle is, we are given this side, this angle. Incident ray makes an angle of 35 degree with the mirror surface only. Not we are not given that the 35 degree is not actually incident ray. The incident ray makes an angle of 35 degree with the mirror surface. So it is not, this 35 degree is not angle of incidence, it is the angle with which the incident ray makes with the mirror surface only. So we need to find, first of all we have to calculate the this degree, this angle of incidence. So before finding that, we know this portion, this is actually 90 degree, right? As the normal is perpendicular, we know the total angle is 90 degree. So to find angle of incidence, we have to subtract 90 degree minus this 35 degree. If you subtract this 90 degree from this 35 degree, we will get this angle. This is the angle of incidence. So 90 minus 35 we have to calculate. We get it as 55 degree. So by laws of reflection we know that angle of incidence is equal to angle of reflection. Therefore the reflected angle of reflection is also 55 degree itself. So we got the answer. We calculated the angle of reflection. Second question is, if a plane mirror is rotated by 15 degree, by how much does the reflected ray rotate? So we are given the plane mirror was rotated by 15 degree. Question is such that, so we know for a fixed incident ray, turning the mirror by theta turns the normal by theta degree. Since angle of incidence is equal to angle of R and both are measured from the normal, the reflected ray turns by 2 theta. Okay, so we get 2 into theta is 15 degree, so the final answer is 30 degree. That is because the normal, hence both I and R are shifted by the mirror's rotation. We come to the fact that it is rotated by a degree of 2 into theta, that is 2 into 15 degree. Now we are going to the third question. A ray strikes a plane mirror at 65 degree. The mirror is rotated by 10 degree. Find the change in direction of the reflected ray. So similar question to that of the previous question. We know for a fixed incident ray, rotating the mirror by theta rotates the reflected ray by 2 theta. That is, if we are rotating the mirror, that is if the mirror is rotated, then what happens? The reflected ray will be rotated by 2 theta angle. Okay, this is the previous formula we learned. So here given that theta is equal to 10 degree. As the mirror is rotated by 10 degree, we know theta is 10 degree. So the change will be 2 theta, that is 2 into 10 degree, we get as 20 degree. Okay, the initial 65 degree, that is, this is the angle of incidence, right? The initial 65 degree does not affect this twice the rotation result. Okay, that is an important thing you have to note. We are asked to find the change in direction of the reflected ray. It is about 20 degree. This is the answer. Fourth question is, the angle between incident and reflected ray is 110 degree. Find the angle of incidence. So this is the mirror, this is the normal, this is the incident ray, and this is the reflected ray. Okay, so the angle between incident and reflected ray is 110 degree. That is, we are given this angle between incident and reflected ray. This angle is 110 degree. We need to find only the angle of incidence. So we know that two I is equal to 110 degree. So I is equal to 110 by 2, which is equal to 55 degree. So this angle of incidence is equal to 55 degree. The next question is, both convex and concave mirror can produce real inverted image. True or false? And justify your statement. This is our question. So before that, we know that a concave mirror is a converging mirror, and it will converge. Similarly, a convex lens, it is actually convex lens. Okay, a convex lens is also a converging lens. So we can say that this statement is actually true, because in the case of a convex lens, for objects beyond the focus, the image will be real and inverted. And in the case of a concave mirror, it will also produce a real and inverted image for objects beyond the focus. So we can say that this statement for both convex lens and concave mirror, both will produce a real and inverted statement. So this statement is true. But it won't be the case with a concave lens. It will change. Actually, concave lens is diverging lens. Okay. So this particular statement is true. Next question is, the angle between a ray and the mirror surface is 25 degree. Find the angle between the incident and reflected ray. So here, this is the plane mirror, this is the normal, this is the incident ray, this is the reflected ray. Okay. Here given the angle between the ray and the mirror surface, that is ray and the mirror surface, this is 25 degree. We need to find the angle between this incident ray and the reflected ray. This total angle we have to calculate. So before that, we know this angle is 90 degree. So to calculate angle of incidence, we have to subtract 90 degree with 90 degree minus this 25 degree, which is 65 degree. If angle of incidence is 65 degree, then angle of reflection is also 65 degree. So we have to calculate this particular angle, which is, since angle of I is equal to angle of 2I is equal to 2 into 65 degree, which is 130. Here. So our next question is, why concave mirrors are used for torches or searching lights, and convex mirrors were rear view mirrors. So, we know in the case of a concave mirror, when the rays are incident on this concave mirror, what happens is that these rays will converge and meet at this particular point, right? They will converge and meet at this point. So, as concave mirrors are converging mirrors, they are used for torches and searchlight. Okay. And in the case of a convex mirror, when the rays are incident on it, they get diverged. That is, they get spread out like this. There will be wide field of view. That's why these convex mirrors are used as rear view mirrors. The next question is, a shopkeeper wants customer to see most of the shop from the entrance. Which mirror he should use? So, in this question, we know that a convex mirror is actually diverging mirror. That is, when light is incident on this mirror, it gets diverged. That is, it gets spread. So, there is a larger field of view. Field of view is larger. So, we get a wider field of view. That is a maximum field of view. So, a convex mirror is being used by this shopkeeper. This is the thing.